Our next step is adding our objects to our scene and making them fly towards our player or slide towards our player because our player is stationary, so our objects have to move towards them. So what we're going to do is we need to first import our models, and then you were told to find those before this video, so you should have some now. Mine, I've chosen the Graveyard Kit from Kinney Assets, so it looks like these. It's got like broken benches and some coffins and, neat things like that. It's even got enemies, which I might implement later. We'll see, but I've got a lot of stuff that I can work with here. So inside here, there are folders for different types of models. If there's more than just two, if there's a bunch of different types of models, there's a preferred types basically that you can use for Unity. FBX or DAE file types are the preferred ones. OBJ file types are always the last resort. So use either FBX or DAE so that you have everything texture-wise wrapped up in your project and ready to go. So I've already made a folder called Environment Models, and I'm going to drag I'm going to drag just the FBX ones in for now. And now whenever I open this folder right here, I can look at all of these different ones. You see there's a little preview right up at the top. I can switch this to model because they're not animated, but it shows me what they look like and which types of things I might want to put in my game, which is great. That's exactly what I want. I want my game to be kind of spooky, so I'm probably going to pick some of the more broken looking things to use for my project, but what you choose is up to you. I also want to add that some sort of kind of randomness to our game so that whenever we are shooting things at our character, they're not going to be the exact same thing repeatedly every time at the exact same interval of speed. So right now, I'm going to go ahead and pick, 3 of these to put out here. Let's try a broken bench. And remember, if you drag it into your scene and then you can't find it, if you click F on your keyboard, that will locate it. It's obviously behind our scene here, so let's bring it closer. Whoop. Now, look at the scale here. The difference between our little character model and our bench here is quite massive. So let's change our scale to, let's say, 0.15 on all of these. What works for me obviously may not work for you. It's up to you to decide what is going to work. Let's zoom in a little bit more and see how far back we need this to go and kind of line it up. Let's see. This will obviously take a little bit of tweaking, and I'm going to try not to spend too much time with it so we can get on with it. But there we go. I'm just going to put it here so I can see how it looks in comparison to her. I think her jump should reasonably be able to go over that size of object, so that's probably a good amount. So I'm going to actually make a separate folder called Prefabs, and I'm going to rename this bench obst, short for obstacle. And then whenever I drag it into prefabs, you're going to get a new sort of message if you have the same type of file I do where it was originally in prefab. I don't want a prefab variant. I want an original prefab. So this is now completely its own separate thing. It has its own identity. And I'm going to go ahead and add in something else. Let's see. Maybe a broken fence. That seems like a good thing for our character to jump over. Quite large, obviously. Let's try our 0.15 and see if that scale makes sense. And bring her down and over. Let's also do maybe some rotation on this so we can see a little bit more of it being a fence. That feels pretty good. Fence. Oh, that's not how you spell fence. Fence, obst. And something else. Grave, maybe? A grave would be a fun thing to jump over. probably a full-size grave. I wouldn't want it to be, oh, I haven't saved this yet. Let's go ahead and save this as a new prefab. Original. And let's bring that forward a little bit. I feel like this one's not going to be need to be quite as small. Let's try 0.25. There we go. So our fence might need to be a little bit bigger, but at this point I'm not going to finick with it too much more. I just want to get the point across that we want several obstacles in our scene and ready to go, because we are going to use the prefabs of these obstacles, and we're going to create an array in which we grab one of them and throw it through. Something we've actually done before with arrays with our block game, if you remember. I believe it was the block game, where we had the different damage assets. It'll be something similar to that. So let's create a new script, and we'll call this obstacle spawn. And this is where we're going to give all the behaviors to our game to how to spawn some obstacles. Alright, so I've already given you kind of a hint, so you might know where this is going. But we need to create an array to store some game objects, which are our obstacles themselves. We need to tell it where to put them, and how often to spawn them, and when to start spawning them. So let's go ahead and set up some serialized fields. Some of these won't need to be serialized forever. Some of them we will definitely unserialize because we won't need to edit them once we've set them. Notice after game object I put the square brackets because we are making an array. Remember, square brackets always have to be attached to an array or it will not work. So let's go ahead and make one. We need a vector 3 position for our spawner because it has an X, Y, and a Z to it, so it's a vector 3. Serialized field. We want to set a float, which again, this will probably not be serialized later because once we're done tweaking it in the inspector and we decide on a happy number, we can set it permanently and not mess with it anymore. Repeat rate. How often are we going to send obstacles out? So here's what we're going to do. First, let's make a method. We'll call this method random spawn, and in that method we're going to instantiate an obstacle from our array randomly at the spawn location and at its current rotation. So first, to run a method we have to start it at some point, so let's call random spawn parentheses saying that this method will run. It's obviously giving me an error, and I can quick fix by generating a method, and it's all set up for me. You could also type it out manually. However you want to do that, that is up to you. And in here, obviously, we need to get rid of that stuff, and we're going to add in our own code here. What we want to do is instantiate an object from a range of the length that we give it in the inspector at a location and rotation. So I'm going to say that way so that you can maybe start thinking about each step of the way and start writing it for yourself, because you need to start thinking about these things and coming up with them on your own eventually. So try to come up with this, what instantiating this object is going to look like. A hint is, you've done it before, you should know how to do this. So instantiate is how we're going to start this. And then we would like to make, in parentheses here, we've got our object original that we need to give. We are going to use random obstacle, the variable we've created for our array, which needs an input because it is an array, and we want to say random dot range, range is capitalized, random dot range, and then in parentheses any range between 0 and random obst dot length. And then outside of that, we need to give it a location. So let's say spawn location, and then let's say quaternion identity. They're used to represent rotation, so basically it's saying the original rotation of the object, we're going to keep that original rotation. So it's going to be a random dot range. What's this error it's giving here? It wants it to be somewhat more specific, but random dot range should work. This is the correct syntax here. So let's save this and go back to our game. We need something to hold all this information, so let's create an empty. We'll call this obstacle. Let's see, we'll just call it object spawner. And then let's put this obstacle spawner on here. Now this script right here, whenever it gets all loaded in, should have a range. Well, actually it won't load right now, so let's give this a second. Let's comment this out and go back into Unity here. Now object spawner has all of the variables. So right now our obstacle length is 0 because we haven't dragged anything in. So let's drag in from our prefabs. We want all of these. So if we click on our spawner, we're going to drag them onto random obstacle and see it auto-fills, and the size goes up automatically. We use something similar for our scenes in the Choose Your Own Adventure story also. We also want this to have a specific location that it's going to spawn from. So I want it to spawn somewhere off screen, and that's probably far enough over. So I'm going to use this position, maybe a little bit high, because I'm going to give my objects some actual weight, so they'll just fall to the ground wherever I put them. So let's set these to 14.5 is probably a nice number, and the y do negative 3.5. It's probably okay. Let's look at where this is, and our object is invisible right now, so it's kind of hard to see. Let's go ahead and give it an icon so that we can see it against our background. I like orange there. So now I can see where it is and where it's going to spawn. I think this will be alright. We may want to move it on the z-axis just a little bit further over so our objects actually spawn and run into our character. So let's say the z is 2.2. That seems like a good spot. Start delay, we don't want them to instantly start popping out, so let's give that a 2. And our repeat rate, we can also say 2. We haven't dealt with these yet. These variables are not used yet. Right now all we're doing is dealing with getting the object to spawn. So now that I have objects in that array, I wonder why it's frustrated with this. Because it is not sure if it should be using system instead of Unity engine. So I don't know why system is actually in here this time. It doesn't need to be. Yours shouldn't have that, and I didn't have this whenever I tested this code, so it should be alright to get rid of it. But now it knows that random.range is in reference to Unity engine's version of random. Now let's see what happens. If I hit play, we should get a random object spawning. Let's pause it. And in our scene here, do we have an object? We do. We have an object. It is very much in the wrong location though. You can see the bench has spawned right there. So our z-axis was indeed very much wrong. So let's make our z -1 looks like a better number. That will make the bench spawn in a good spot. Let's stop the play and go in and fix this. So we want our object to spawn at -1. Now if I were to hit play, and she's running, none of the obstacles are moving towards her yet, but when I hit pause, we can see it has spawned a fence this time, which indeed means that our random spawning is working. It's spawning something random and it's just throwing it there, and we will deal with it moving here in just a second. So we've got that all figured out. We don't need to play this any longer. Now, we want this script to run repeatedly. And a straightforward, pretty simple way we can do this is we can use a bit of code called Invoke Repeating, which basically just means we're going to take this code, this method, and just repeat it over and over and over again. So instead of just calling the method like so, I'm going to comment this out, we can use Invoke Repeating, and you can see it invokes the method name in time seconds and then repeatedly every repeat rate seconds, which conveniently, you might notice, we used repeat rate as our float value. So let's say invoke repeating, and then in parentheses we need our method name as a string, and note a string always has parentheses or quotation marks around it. Our method name, in this case we actually do not need the open closed parentheses. We want to use our start delay that we set up, and we want to use the repeat rate that we set up. The reason we're doing it this way instead of hard coding numbers in is of course so we can tweak it and adjust it at a later date if we would like to do so. So now when I go back into Unity, I'm actually going to move this spawn location over here so we can see it happening on the screen. Let's see. That is, the position is now shifted to, let's call it -0.5. And if I were to hit play, I should get 2 seconds, and then something spawns, something else spawns, another thing spawns. Notice they are just randomly spawning. They're spawning directly on top of each other in the exact same location, which is not, ideal, but is going to work for our purposes. So let's move this back over here, and I'll make this, I don't know, now it's at 21. I know it was at like 14 before. It doesn't really matter. Now we need to give our object some weight and some collision, because we need to know when our character is going to hit it, correct? Or else it's not an obstacle. So let's go ahead, and each object needs to have a rigid body and a box collider. The rigid body will, so that will have weight and will physically be on the ground, and we'll be able to use the rigid body to move it. So let's give it a rigid body and a box collider. And let's look at this box collider and see that it is a good size, just to double check. Sometimes whenever you're importing objects, it's not a great size, and you want to make sure that you're not making it unfair to your players. I actually might shrink in the sides just a hair, because her body coming into contact with it will be slightly outside of that. So I'm good with that. And then remember to do your overrides and then apply it to all of your bench obstacles so that whenever it's spawning from your prefab folder, it has those things, and do the same thing for your others. So now that you've got your rigid bodies and your obstacles figured out, I'm actually going to show you just kind of the difference that that made in spawning. So say our spawn location is set back at -1, and then I hit play. Whenever we spawn things, instead of them just spawning and floating in the air, they drop to the ground. They won't be doing it visually on the screen because they'll be off in the distance to the right somewhere doing that. You notice they now interact with each other because they are physical objects, which is great. That's what we want. Back to 21 for you. Okay, now that our objects have that, we also need to make sure we tag them as objects that we want to recognize as obstacles. So we're going to have to create a custom tag for that. Let's call that obstacle. And make sure we set all of our obstacles to it and override that as well. Oops. Obstacle. And apply it to all. Okay. Now we have our obstacles all set up so that they are recognized as obstacles, and whenever they run into our character, we need to check and see if that obstacle does something, basically. So let's go ahead and set up a way to make it so that our obstacles actually move towards us. We're actually going to create a separate method for this because we don't necessarily need it tied to just the spawner. We might want several things to have the ability to move left. So we're going to create just a script all by itself called move left. So in our move left script, we need to do exactly the same thing as our parallax effect, basically. We're going to take our transform and translate it to the left to the effect of time.delta time and the speed. So let's give this a variable called Serialized Field float obst speed for now. And we're going to take the transform dot translate, and it's always better to type it all out so you remember your code instead of copying and pasting, which would be tempting. And times obst speed. Save that. So we want to apply this script to our objects so that our objects have the ability to move whenever they are spawned. So let's take obstacle and put it on our objects, or move left rather. Double check that they all have move left on them. Move left script, and again, apply your overrides. So I'm going to go ahead and delete these 3 from here because we are going to spawn some fresh ones. Now what should happen is I should hit play, and the objects that spawn should go ahead and drop to the ground and then start moving left. We see an obstacle has generated, but they are not moving left, so let's check this out and see what it looks like in the scene view. They're just appearing and falling over. Let's hit play. Oh, you know what? I bet you caught this mistake and I did not. I did not give them a speed. So let's give them a speed. Let's say 10. Just 10 for all of them. I'm changing it on the prefab itself. You'll notice that as we work on this project, you just get more and more things that if you don't keep track of them, bad stuff will happen. And you'll notice that I ran into the obstacle and the game continued carrying on and my player was just spinning around everywhere. What we actually want to happen is we want to check our tag and see if it is an obstacle that we've collided with, and if it is an obstacle, we need to make sure that we stop the game But now we have objects spawning very rapidly. It feels like maybe our gravestone is a little bit tall. That's something we can tweak as we work. And something that maybe is not like we set it up exactly perfectly just yet, but that's why we have these variables and these prefabs that we can tweak and make smaller as needed. So the next step is adjusting our objects to make sure we can jump over them, and then we need to take our player and check and see if the obstacle that we are running into is tagged as obstacle. And if it is an obstacle, we need to do something, probably go to a game over scene. So now that you've got your spawning set up, you probably should go ahead and set up a game over scene, or you could even do a splash screen, kind of like your pause menu before if you'd like, that you can turn off and on. I will let you choose. You can do either of those things. So if you would prefer to have just a window pop up that says game over replay and it doesn't reset anything, it doesn't load a separate scene, you can. So go ahead and get your in-game setup, and then I challenge you to go ahead and see if you can take your collusion method that you already have set up and also check if the game object is tagged with obstacle, and then set it to make it so that we turn on the game over scene and make it so that we have to have an ability to restart. So go ahead and work on all that. That's your challenge for this video.